A turbocharger uses the energy in an engine's exhaust gases to produce compressed air, which it feeds back into the engine. By doing this, it plays a big part in enhancing the engine's performance and reliability. MET turbochargers were developed and are produced by Mitsubishi Heavy Industries. With high reliability and efficiency, they are used on engines around the world. A MET turbocharger incorporates a silencer, a scroll, a gas casing, and a pedestal. On the inside, it has high-speed rotating components such as a turbine rotor, turbine blades, and a compressor impeller. Maintaining high turbocharger performance at all times is vital to ensure high engine performance and reliability. This means it's essential to understand the structure of the turbocharger and to apply this knowledge in turbocharger maintenance. In this video, you'll see how a MET 83 SE turbocharger is disassembled, inspected, and reassembled. The internal parts of the turbocharger must be cleaned and inspected periodically, depending on the combustion condition, operating hours, and other attributes of the engine. First, disconnect the turbocharger side wiring from the tachometer cable's terminal box. Then, connect a hoist to the silencer using a cable and remove the retaining nuts. When removing the silencer, make sure it does not come in contact with the tachometer cable's protective pipe. Place the removed silencer in a safe location. Use rope or some other means to secure it so it doesn't tip or fall over. Before removing the air inlet guide, use a clearance gauge to measure the clearance between the air inlet guide and the impeller at 4 locations: top, bottom, left, and right. These data will be necessary during reassembly. Remove the hex bolt from the inner scroll using the hex key. Attach the slinging device to the inner scroll. Make sure the slinging device and scroll are in tight contact with each other. Do not use bolts that are longer than the T16 bolts. Using bolts that are too long could cause the flange to split. Next, screw the 2 lifting screws into the holes on the left and right of the flange. When you do this, screw the lifting screws carefully so that they are the same depth on the left and right, and pull out the inner scroll. Lift slowly using a cable. Stop lifting when the cable is under tension. Gradually pull out the inner scroll and remove it. The clearance between the inner scroll and the impeller is small, so be careful not to let the impeller come into contact with the inner scroll. There is a diffuser attached to the inner scroll. When storing the inner scroll, secure it so it doesn't tip or roll, and be careful not to damage the diffuser. If there is a heat-resistant lagging on the mounting flange, you will need to remove the lagging. Attach the slinging device to the gas inlet inner casing using the bolts. Remove the nuts from the mounting flange on the gas inlet inner casing. Screw the lifting screws into the holes on the left and right of the flange. When you do that, be careful to screw the lifting screws to the same depth. Lift slowly using a cable. Stop lifting when the cable is under tension. You'll now be able to pull out the casing. There's a nozzle attached to this gas inlet inner casing. Secure the casing in a safe place. Use a clearance gauge to measure the clearance between the gas outlet guide and the tips of the turbine blades at 4 locations: top, bottom, left, and right. These data will be needed for comparison during reassembly. Now measure the thrust clearance. If the thrust bearing is full of lubricating oil, you will not be able to take an accurate measurement, so give the rotor shaft at least 10 turns. Set the dial gauge on the end of the rotor shaft. The thrust clearance is the difference between the shaft deflection when the shaft is pushed and the shaft deflection when the shaft is pulled between the compressor side and the turbine side. Take at least 5 measurements and check that the values do not vary. Remove the cap and fastening bolt from the end of the impeller. Measure the distance from the end of the rotor shaft to the surface of the nut. You'll need this dimensional value for checking that the amount of tightening is correct after reassembly. Next, attach the dial gauge to the end of the rotor shaft. As you manually turn the rotor clockwise, use the dial gauge to measure the deflection of the rotor shaft. These data will be needed for comparison during reassembly. Attach the stay. By preventing the rotor from falling out, the stay will serve as a support to enable safe removal of the rotor. Before anything else, Use a brush or compressed air to clean out the threaded hole in the end of the rotor shaft. Screw in the rotor pulling out tube. On the gas inlet outer casing, mount the stay with the roller support assembled on it. After making sure the ram of the hydraulic jack is tight, screw the hydraulic jack into the end of the shaft. While doing this, hold the jack securely with your hands to prevent it from falling and damaging the impeller. When you have screwed the jack in fully, give it one reverse turn. Place the hydraulic pump with the hose connected to it on a flat surface. Raise the pressure of the hydraulic pump to the specified level. For the MET 83 SE turbocharger, the specified pressure is 65.7 megapascals. Insert the rod through the slot in the hydraulic jack into the hole in the shaft nut. Using the rod, turn the shaft nut counterclockwise to loosen it. If the nut does not loosen, reduce the pressure to 0, then raise the pressure to 120% of the specified level and try to loosen the nut again. If the engine has just been stopped and the impeller is still hot, the thermal expansion of the impeller will make it impossible to loosen the nut at the specified pressure. Reduce the hydraulic pump pressure by opening the relief valve. Carefully remove the jack from the shaft. Remove the impeller's retaining nut. Screw the protection bolt into the end of the rotor shaft. Attach the impeller removal fittings to the boss of the impeller using a bolt. Slowly turn the handle with the other hand to pull out the impeller. Now remove the handle. Screw the slinging device to the impeller drawout tube using the handle. Change the position of the shackle on the slinging device. Lift slowly using a cable. Once the impeller is separated from the rotor shaft, support its weight and set it down horizontally, taking care not to damage it. Do not forget to remove the protective bolt from the rotor shaft. Use the threaded bar on the threaded part in the sleeve and pull out the sleeve. Remove the support retaining bolts and attach the guide bar. Screw the lifting bolt into the threaded hole in the flange part of the support. Then lift the support and remove it. The compressor side oil labyrinth and thrust bearing are attached to the support. When storing the support, place it with the thrust bearing metal side uppermost. With the support removed, you'll be able to see the thrust collar. Remove the thrust collar slowly and carefully using the threaded bar. Screw the rotor guide pipe into the rotor shaft. Attach the support to the compressor end of the bearing pedestal. Make sure the support is free of damage, burrs, and dirt. On the stay that was attached earlier, use the lifting screws to adjust the height of the roller so as to slightly raise the rotor shaft from the bearing. Pull the rotor shaft pulling out tube so as to pull out the rotor shaft as far as the stay that was attached a little while ago. Put the cable around the large diameter part of the disc end of the rotor. Remove the stay and completely take out the rotor. When you store the rotor shaft with the pulling out tube removed, take steps to prevent the turbine blades from touching the floor. Remove the retaining bolts from the gas labyrinth. Screw the removed bolts into the threaded holes and remove the gas labyrinth while lifting. Next is removal of the turbine side oil labyrinth. Fasten the support, using the bolt, to the oil labyrinth. After fastening and after lifting the oil labyrinth using the bolt, remove the support and the oil labyrinth. Remove the turbine side journal bearing. For the turbine side thrust bearing, use the hex key to remove the hex bolt. Then remove the turbine side thrust bearing by hand. Be careful not to drop the bolt. Remove the compressor side journal bearing using the threaded bar. Disassembly of the MET 83 SE turbocharger is now complete. Store all the removed parts in a safe place and keep them clean. The turbocharger's performance can deteriorate if its components become worn and dirty during use. To prevent performance from deteriorating in this way, regular inspection of components is essential. Now remove the compressor bearing and oil labyrinth from the support. Use a hex key to remove the thrust bearing side hex bolts. Screw the same bolt into the threaded hole in the compressor side thrust bearings to lift the bearings. Then remove the bearings. Turn over the support and pull off the compressor side oil labyrinth. If a thrust bearing becomes worn, the tapered part gets smaller, and the ratio of the flat part to the tapered part gets bigger. To check the extent of wear, first put a thin, even layer of red ink on the thrust collar. Gently place the colored side of the thrust collar on the metal surface of the bearing. Gently turn the thrust collar in the direction of rotation. Then, lift off the thrust collar and observe where red ink has been transferred to the bearing. If the red ink shows that the ratio of the length of the tapered land to the length of the flat land is from 4:1 to 2:1 on the compressor side, and from 2:1 to 1:1 on the turbine side, replace the thrust bearing with a new one. For details of standards that may or may not be used when judging tapered land comparison, please check the instruction manual. If you have difficulty making an evaluation, it is advisable to replace the thrust bearing with a new one. If the metal surface of the bearing is deeply scratched, has multiple scratches, has surface separation, or is cracked, replace the thrust bearing with a new one. Please inspect the turbine side thrust bearing in the same way. If you closely observe the rotor shaft, you'll be able to see the sliding widths relative to the journal bearings. These parts of the rotor shaft are the journals by which the rotor shaft is supported. Install the journal bearings on the removed rotor shaft. With this journal bearing sliding part, use a dial gauge to measure the clearance between the inner surface of the journal bearing and the rotor shaft with the upper side of the inner surface pressed against the shaft. Compare the measurement with the clearance standard table. If the metal surface appears to have many scratches or to be deeply scratched when you perform the inspection, replace the bearing with a new one. Do not attach the dial gauge to the rotor shaft. If you did, the rotor shaft would get magnetized. A pin for locking is located on each journal bearing. If the pin diameter has been worn by 20% or more, or the pin is bent, replace the pin with a new one. Measure the diameters of the sliding parts and the diameters of the adjacent areas. If the diameter of either sliding part is at least 0.02 of a millimeter smaller than the diameter of the adjacent area, please contact Mitsubishi Heavy Industries. Make sure the claw clutch of the impeller is free from abnormalities such as gouges and cracks. If at all possible, perform a die penetration inspection on the back of the impeller and on all of the blade surfaces. If the inspections show any defects, replace the impeller with a new one. The impeller is made of heat-resistant aluminum alloy. To clean the impeller, wipe it with a sponge or other soft item soaked in kerosene or warm water. Do not use a wire brush or any other hard object. To clean the turbine blades, dip them in a container of warm water to remove the deposited scale. After removal, clean the blades. After washing the turbine blades, dry them thoroughly and coat them with rust-proofing oil. Note also that the turbine blades are made of magnetic material, so it's possible to perform magnetic particle inspection on them. Like the turbine blades, clean the nozzle after washing in warm water. After cleaning the nozzle, dry it thoroughly and coat it with rust-proofing oil. To inspect the nozzle, place it on a stable, flat surface in a well-lit location and give it a visual check for abnormalities. The air filter must be cleaned at least once every 2 months. Soak the filter for 2 to 3 hours in lukewarm water in which a cleaning agent has been dissolved. Then gently wash the filter by hand. After washing the filter, dry it thoroughly by placing it in a shaded location that's well ventilated. The vacuum breaker is attached to the side of the pedestal. Remove the bolt, pull out the vacuum breaker, and make sure that there's no abnormality in the valve disc and that the valve operates smoothly. There's an inlet for sealing air near the diffuser blades on the pedestal compressor side. Check that there's no evidence of lubricant leakage into the sealing air channel. Also, check the continuity of the channel by feeding general service air into the channel and confirming that air emerges from the turbine end. The procedure for reassembly is basically the reverse of that for disassembly. Before starting reassembly, though, you must thoroughly clean the rotor shaft, bearings, and other components, and make sure there's no foreign material in the pedestal. Also, replace all tongued washers, O-rings, gaskets, lock plates, stainless steel wires, and other consumable parts with new ones. When installing the bearings and the rotor shaft, take off your work gloves and work with bare hands. Take care not to allow foreign matter to contaminate the components. For reassembly, follow the disassembly steps in reverse. Install the compressor side journal bearing to the bearing pedestal. Install the turbine side thrust bearing. Install the turbine side journal bearing to the bearing pedestal. Install the turbine side oil labyrinth. Install the gas labyrinth. Attach the support to the compressor side of the bearing pedestal. Attach the rotor guide pipe to the compressor side of the rotor shaft. Attach the pulling out tube to the turbine side of the rotor shaft. Put the cable around the large diameter part of the disc end of the rotor. Clean the rotor shaft and apply plenty of lubricating oil to the area over which the bearings will pass, from the rotor guide pipe periphery along the rotor shaft. Slowly insert the rotor shaft into the pedestal, taking care not to damage the fins of the turbine side oil labyrinth. Coat the turbine side thrust bearing and thrust collar with lubricating oil. Screw the threaded bar into the thrust collar and attach the thrust collar to the rotor shaft. Attach the support with the compressor side thrust bearing and oil labyrinth on it to the pedestal. Insert the sleeve partway along the rotor shaft and align the match-up markings on the sleeve and rotor shaft. Align the claw clutch of the impeller with the groove in the sleeve. As you do this, make sure the match-up markings on the sleeve and impeller are aligned with each other. While observing the back of the impeller, push on the impeller so it engages precisely with the sleeve. When you've confirmed the fit between the impeller and sleeve, push the impeller all the way in by hand. Then fit the nut onto the end of the shaft and tighten by hand. Then screw the hydraulic jack into the end of the shaft. When you have screwed the jack in fully, give it one reverse turn. Install the hydraulic pump and raise the hydraulic pressure to the specified level. After raising the pressure, insert the rod through the slot in the hydraulic jack and use it to turn the nut until it stops. Open the relief valve and reduce the hydraulic pressure. Increase the pressure to the specified level again. Check that the nut cannot be turned further. Remove the hydraulic jack. Use a vernier caliper or depth gauge to measure the distance from the end of the surface of the nut to the end of the shaft. Compare the value with the one obtained before disassembly and confirm that the difference is less than 0.1 millimeter. Turn the rotor shaft by hand clockwise. Confirm that it rotates smoothly and without contact noise. Set a dial gauge on the end of the rotor shaft and use it to measure the deflection in the end of the rotor shaft. If the deflection is 0.1 millimeter or greater, there may be foreign matter on the contact surface of the impeller, sleeve, thrust collar, or rotor shaft. When you do this, remove the impeller again and check the contact surfaces. Now measure the thrust clearance. Set a dial gauge on the end of the rotor shaft just as you did before disassembly. The thrust clearance is the difference between when the shaft is pushed and when it is pulled. Check that the clearance is the same as it was before disassembly. Use the clearance gauge to measure the clearance between the turbine blades and the gas outlet guide at top, bottom, left, and right. Check that the clearance conforms to the standard value, and for details of clearance standards, please refer to the clearance table in the instruction manual. As you did during assembly, make sure there is no contact with the impeller. Fit the inner scroll to the outer scroll and attach with the hex bolt. Use the clearance gauge to measure the clearance between the air guide casing and the impeller blade tips at top, bottom, left, and right. Check that the clearance conforms to the standard value, and for details of clearance standards, please refer to the clearance table in the instruction manual. Hoist the silencer and fit it to the scroll. Tighten the retaining nut firmly. Connect the tachometer cable to the terminal in the terminal box. As you've seen, the MET 83 SE turbocharger is designed so that people with a reasonable amount of experience can disassemble, inspect, and reassemble it. Nevertheless, the procedures include dangerous tasks, such as hoisting heavy components. It is vital for people performing these procedures to have the skills and knowledge needed to work safely and for them to work under safety control. Carefully reading the MET 83 SE turbocharger instruction manual and understanding its content will help enable you to work safely. Using your knowledge of both engines and turbochargers, you'll be able to play a role in ensuring safe voyages.